Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 733. Please turn to it. Page 733. Today's our lesson number 90. On that page you will find two problems, number 15 and 16. The very last two problems in the section. Of course, these are hard questions. I'm going to start with number 16 first, and then we'll go to number 15. In case you don't need help on number 15, then you don't have to watch the second part. Number 16 is what we're going to do first. It says, after the first term, each term in the sequence is 3 greater than 1/3 of the preceding term. If t is the first term of the sequence and t is not equal to 0, what is the ratio of the second term to the first term? It's an algebraic question, as you can see here. It's an algebraic question because the answer choices involves variables, and you can see even if the answer choices were numerical, it could still be the algebra problem. This is an algebraic question. And therefore there are two ways of tackling it. As I always remind you, whenever we come across an algebra problem in the SAT, as I always remind you, whenever you see an algebra problem, there are two ways of doing this algebra problem. One is what I call the classical way, the traditional way, the orthodox way, the conventional way, the geeky way, the nerdy way, the academic way, the algebraic way, the proper way. And the other one is the quick and dirty way, where you make up a number for the variable, and by doing so, you convert this algebraic problem into a very simple arithmetic problem, and you go with that. Let's do that way first. Let's plug in numbers here and see what happens. Okay? Now, when you're plugging in numbers for the variable, you have to be smart about it. In theory, you could plug in anything that you want for t. For example, if I wanted to, I could plug in 37.375 for t, but that will be idiotic. I could also plug in 3,437,000 for t, and that will be fine too, but that will again be idiotic. You have to plug in some number that is easy to work with. Here, as you read the problem, we are told that after the first term, each term in the sequence is 3 greater than the third of the preceding term. That tells us that we're going to have to take the third of the term. So let's plug in some nice multiple of 3 for the first term. Let's pretend that the first term equals 9. We're going to pretend it. In other words, we're plugging in 9 for t. We're plugging in 9 for t. In which case, the second term, we are told, second term is 3 more than the third of this guy. Third of 9, and then 3 more than that. That's it. What's the third of 9? Third of 9 is 3, and 3 more than that, so that's 6. That's your second term. And the question simply is, what is this ratio? Second term to the first term. Well, second term is 6. The first term was 9. The ratio is 2/3, and this is what we call our punchline. This is our punchline. That's it. Now all we have to do is go through the answer choices. Wherever we see t, replace it with 9, work on it, and see if it gives you the punchline. Whichever one gives you the punchline, that's the answer. Let's start then. A says, I'm going to do it on the top because this is getting too low, or maybe we can do it here. A says t plus 9, t is 9, so 9 plus 9 over 3. Well, that's 18/3. 18/3 is 6. 18/3 is not 2/3. That's not the answer. B says t plus 3, which is 12/3. Well, 12/3 is going to be 4. That doesn't give us 2/3. We're looking for our punchline. The punchline is 2/3. B is not the answer. Let's look at C. C says t plus 9. T is 9. So t plus 9 is going to be 9 plus 9 over 3 times t. 3 times 9. Let's see what that gives us, shall we? So on the top we have 2 times 9. On the bottom we have 3 times 9. What do you know? The 9's cancel out and we get our 2/3. There you go. There is your answer. The answer is C. So that was one way of doing it, which is the non-algebraic way. You plug in numbers or variables, we plug in numbers for the variables, and we convert the algebraic problem into a simple arithmetic problem if you are one of those people who is not very comfortable with algebra. Now, if you happen to be very good with algebra and if you're very comfortable with it, if you're very conversant in it, then by all means go ahead and do it the algebraic way. And the algebraic way will go something like this. Algebraic way will go something like this. The first term we are told is t. Therefore, the second term is going to be, we take a third of that and we add 3 to it. Because it's 3 more than the third of the preceding term. The third of the preceding term, the first term is t, then the third of that is going to be t over t. And it's 3 more than that, so we add 3 to it. And we just look for the ratio. Ratio of second term to first term, so it's t over 3 plus 3 over t. We have to make the denominator the same. Right now this guy has a denominator of 1. We have to make the common denominator so we can add the top part. Let's multiply the top and the bottom by 3. And this is what I mean. If I have to explain this part, then you're not cut out for the algebra. Do you understand? I don't mean that as a derogatory term, but you have to be realistic. If you're very good in algebra, then by all means do it the algebraic way. If the algebra is something that you're not too sure about, then stick with the plugging in technique that I just showed you. So again, now they have the same denominator. This is 3 and this is 3. 1 times 3 is 3. They have the same denominator, so we can add them up. So we get t plus 3 times 3, which is 9. So we get t plus 9 over 3, and then over t, which is going to boil down to t plus 9 over 3t. And that's it. That was our answer. That's exactly what we found. And that's answer choice C. That's answer choice C. Do you understand? Let's go on to number 15. I just used the word a little while ago. I said, if you're conversant in algebra, then by all means stick with algebra. Do it the algebraic way. What does it mean to be conversant at something? Let's learn it, shall we? Let's learn that word. That's it. We're done with this part. I'm going to erase it. I'm going to take a sip first. What does it mean to be conversant at something? I am not quite sure 100%. I do not know why I brought this up, this word, because now I do not know whether the proper expression is conversant at or conversant in. I'm going to leave it up to you to find it and learn it properly, okay? Because sometimes, being a non-native speaker, I make mistakes, I make boo-boos when it comes to English language. But the good news is that most of the time when I do make a boo-boo, or if I'm not sure about it, I am cognizant of it, I'm aware of it, and I always tell you that I'm not sure about it, you figure it out yourself. Did we ever learn the word conversant? I'm looking at my vocabulary list here. Oh, there you go, day number 3. Just type in vocabulary day 3 and you will learn this word, along with some other useful word to help you expand your vocabulary. Number 15. In number 15, we're given 2 triangles here. They look something like this. This is the arrow here, there's another arrow, there's another arrow, and then the 4th arrow. And this part we are told is n. What is the question asking? What is the sum in terms of n of the degree measures of 4 angles marked with the arrows? The 4 angles that I just showed you, marked with the arrow, we're looking for their sum. Well, let's see what we can do. Well, if you look at this line here, let's give this point's name here. Let's call them A, B, C, D, and E. If you look at the line AD, it looks something like this: A to D. And what do we know about the degree measure of a straight line? A straight line, measure of degree is 180. Because as you can clearly see, a straight line encompasses semicircle. Therefore, the straight line is 180. Part of that is n. If this part is n, then the remainder portion of A to D must be 180 minus n. So that's the first thing we have to understand. The second thing we need to understand is that when we have 2 straight lines, when they intersect, there is one line, here is another line. If this line happens to be 180 minus n, as we just found out, then this angle will also be 180 minus n. Because opposite angles are equal. These angles are called opposite angles. They are also referred to, in the proper terminology, would be vertical angles. Vertical angles are equal to each other. So if this is 180 minus n, we just found out, then so is this one. This angle is also 180 minus n. Please stay with me in this story. This angle was n, we are told, therefore this angle is n. Okay, stay with me in the story. Now, third thing we have to ask ourselves is, what is the sum of the angles in a given triangle? The sum of the angles in any triangle. Doesn't matter what the triangle looks like. It doesn't have to be right angle or isosceles angles. It doesn't have to be a right triangle or an isosceles triangle or an equilateral triangle or an obtuse triangle or an acute triangle or an ugly triangle. It could be any kind of triangle. Sum of the degrees of sum of the angles in a triangle, in any triangle, is 180. Therefore, this angle plus this angle plus this angle in triangle ABC, in triangle ABC, their sum is 180. Similarly, in triangle CDE, their sum is 180. 180 plus 180 is 360. If we subtract this angle and that angle, what we will be left with is the sum of these four angles, which is exactly what we are looking for. Sum of these two angles are simply 2. Did I say R? The sum of these two angles is, not R. Sum of these two angles is simply 2 times 180 minus n. 180 minus n on this side, 180 minus n on this side. So it's 2 times 180 minus n. Open the parentheses. Negative 2 times 180 will give us negative 360. Negative 2 times negative n will give us positive 2n. Negative 360 and positive 360 right here will cancel out. And the answer simply is the sum of the measure of these four angles that they show with the arrows happens to be 2 times n. It was a tricky one, wasn't it? It was a tricky one. The answer is 2 times n, which is answer choice B. That's it. We finished this exam, day number 90. That was the end of exam number 6. This book contains 10 exams. As I told you on the very first day when I started this process, that I intend to go through every single math problem in all 10 exams. And it takes me 15 days to do one exam. There are 3 sections in each exam, and we cover each section in 5 days, in 5 clips. So it takes 15 videos to make one exam. Today was day number 90. That was the end of our exam number 6. We have 3 more exams to go. And stay with me and we'll finish the journey. You understand? Do I have 3 more exams to go, or do we have more? We have 4 more exams to go. This was the end of exam number 6. I'm not a math person, you understand? This was the end of exam number 6. We have exam 7, 8, 9 and 10. Of course we have 4 more to go, because I realized as soon as I said 3 more exams, I realized that 3 more exams would have been 45 days, because it's 15 videos per exam. 45 plus 90 does not add up to 150, and I knew there were 150 videos altogether that's going to be, because it's 15 times 10. Anyway, I will see you tomorrow, okay? Bye now.